Everybody was kung fu fighting.
Test 1, 2. Sehr gut. So, anybody not speaking German? Okay, fine. Yeah, perfect. Just so that if everybody speaks German, then you don't have to listen to a German speaking English with a bad German accent. Okay, welcome to everybody's Git Fu Developing. My name is Sebastian. I'm from Munich, working at Check24. I'm doing development for roughly 30 years now. So, and I would say 10 years of those with Git. In my free time, I do a little bit of open source, mostly my own two pet projects, Captain Hook and PHPBU, but that's all you hear from them today. Like everybody else, I'm saying stupid stuff on the internet, so if you care, you can follow me on Twitter. And if you have any questions, just tweet at me. Normally, I try to be there quite frequently. So, Git. When I look at Git histories, they often look something like this. And as you can see, that's most of the time not very useful. And so what I want to talk about today is what you as a developer can do to improve your Git repository or your Git commit history and to make it more efficient, more precise, and cleaner. And I want to start with something that's called atomic commits. And when we look at a commit like this, implemented new voting feature, fixed an internal messaging issue, and refactored some inheritance menace. Oh, sorry. And that's an awful lot in that commit message. There's happening so much, and that's not what I would call atomic. So how could this look like if we use atomic commits? So if we use atomic commits, it's maybe looking more something like this. Add voting persistence service, refactor formatters to be composable, fix internal messaging issue, and add voting API endpoints and actions. And especially if you work with different teams or a lot of developers together, maybe someone needs your fix that you did in the messaging issue. If you do atomic commits, what he can do now is he can cherry pick exactly this commit. And he can say, OK, I need this bug fix in my feature branch as well. And then he can just cherry pick it. If you would have done it in the previous one, you have to send him a patch or even copy-paste stuff, and then merging again, you would have conflicts and all that stuff, so not very nice. And another really great benefit of atomic commits is if you're doing code reviews. Who of you is doing code reviews? That's most of you, I would say. Not all of you. If you're not doing them, start doing them. It's maybe one of the easiest and most effective techniques to improve the code quality in your team. But if you're doing code commits, like I said, you should. And we see something like this. We have one commit, and in this case, 17 files changed. That's not too much, but expect something like 54 files change or something like that. You would have no place where to start. As a reviewer, you would look at this and say, OK, fine, 17 files. Where should I start looking? And you have only one commit, and that's like telling you everything and nothing, maybe at the same time. And if you would use atomic commits, what you could do is you could use the commits as a guide through your thinking process and can say, OK, first I did this, and I changed these files. Then I did that, and changed the other files. So what I do in a code review is most of the time I go to the commit tab and open every commit tab, every commit in a new tab. And then I switch through the tabs and can kind of follow the thinking process of the developer and try to understand what he intended to do with the feature. So that's really, really nice and really helpful. It makes my job as a reviewer or everybody else's job as a reviewer much, much easier. So of course, Master Uguay has some rules for atomic commits. They should be about a single, irreducible, and now it's important, useful set of changes. And so it's not, I added like an empty method, and then I added the first line of code to my method, and then I added the second line of code to my method. That's not very useful. So really do useful commits. The maybe most important thing is that everything works. You want to have every commit that you do in the end be deployable to production. So nobody should care if this one or the next one is going to production. Everything should work if you do a commit. And a nice rule of thumb is don't use the and in commit messages. Just don't. If you have to use and, that's most of the time telling you, okay, that's not atomic. Maybe I have to split the commit up and do some things separate to make them atomic and more usable and understandable. And that leads me direct to commit messages. Who of you knows the website whatthecommit.com? Not that many. So whenever you are looking for a great commit message because you have no idea what you should put in there, just go to whatthecommit.com and you get presented some gems like major fix-up, fixed PO, one.nos simply merge into master, or my absolute favorite, best commit ever. Of course, that's not what you should do. So, of course, Master Uguay has some rules for commit messages as well. The first rule is separate the subject from the body with an empty line. And then most developers look at me funny and say, body? What are you talking about? A commit message is like 4 words. And no, it's definitely not. But we see an example in a bit. So, next one is limit the subject line to 50 characters. And we will see an example later why that's important. But yeah, just try to be very precise and very short in the first line of your commit message. Then do not end the subject with a period. That's kind of arbitrary, but since we are limiting ourselves to 50 characters, it's always nice to, yeah, we don't use a period, we save 1 character and we can write longer commit messages. Next one is capitalize the subject line. And that's arbitrary as well, but I don't know about you, but when I look at the commit history and I see uppercase, lowercase, uppercase, lowercase, uppercase, lowercase, lowercase, then that cringes me out. I can't stand that, but I'm kind of special in that way. So, but yeah, anyway, you should follow the rule, right? Then some important stuff, use the imperative mood for the subject line. And imperative means you shouldn't use the past tense, like updated or fixed. Is anybody writing commit messages in German? No. Oh, you do? Then this is kind of weird. But in English, it's much easier. But we will look at an example right away. And then we have wrap the body at 72 characters. So even if you have a subject line and 50 is the limit there, if you then start typing a body, please wrap the lines at 72 characters, because old people like me are using the terminal, and they really appreciate if they don't have to side scroll in the terminal. So please do line breaks after 72 characters. And a very important one, and the last one, is use the body to explain what and why versus how. Because how you did something, the code should tell me that. So I know what you did in terms of achieving the goal of the feature. But why have you done it? That's totally, yeah. If you don't tell me, then I have no idea why you choose that kind of implementation. So let's have a look at the subject line. So here's the subject line, and you see, here's the problem. Most UIs like GitHub, GitLab, Bitbucket, they strip the commit message after 50 characters. And most of the time, it's like, I updated some very important ... Okay, what did you do? And then I have to kind of dig in and have to click to see what's actually happening. So it's kind of important to make put the important stuff of your commit message in the first 50 characters, and then just do a line break. And then what I said, the imperative mood. Why should we do that? So first, because Git is doing it as well. So whenever Git is proposing a commit message to you, it always uses the imperative mood. It never uses past tense or something else. So it's not merged branch my feature, it's merge, right? And the nice guide, if you want, you can follow the sentence, if applied, this commit will, and then your commit message. And like I said, that is kind of strange in the beginning, but it makes commit message much more precise. And the imperative mood is shorter as well, so it's much easier to follow the 50-character rule. So let's look at some examples. This will fixed bug doesn't make sense. This will changing behavior doesn't make sense. And this will added sweet new API methods. Nah, I don't know. So it should look like this. This commit will merge branch feature X. This commit will update the getting started documentation. This commit will remove all deprecated methods. And this commit will prepare version 1.0.0. So a full example could maybe look like this. So we have like a 50-character subject, then the blank line that's separating subject from body, then the body wrapped at max 72 characters with whatever information you want to put in there. And you don't have to use the imperative mood in the body. In the body, you can use whatever you want. So the body should, only the subject line should be in the imperative mood. And of course, not every commit message should look like this or has to look like this. But if you're preparing big features, or if you even combining commits together, so you squish commits after merging features or something like that, then especially commit message should look like this, with what decisions did we do during the development process? Why did we choose one implementation over the other? What are maybe edge cases and all that stuff? And of course, you can put your issue numbers or whatever in there as well. So they're really nice. And this way, your commit messages are really, really helpful. But let's say we have good commit messages and we do atomic commits. Mm-hmm. Anybody of you doing Git Flow or knowing Git Flow? Yeah, then maybe you know something like this, right? A nice Git graph. It's more like a Guitar Hero graph, right? So that's not very useful at all. And that's because Git Flow is telling you merging every branch into every branch, and it's getting really, really complicated. So most of the time, I would advise you, if you don't have long-running releases, like if you have a version 1 and you have to support that version 1 and have to always create version 1.0.5, even if you have already version 2, then Git Flow is for you. But if you only progress forward and don't have like long supporting versions, don't use Git Flow. It's much too complicated. But so the Git graph like this is not very useful. And Master Uguay says, your mind is like the Git graph, my friend. When it is agitated, it becomes difficult to see. But if you allow it to settle, the answers become clear. And so why is this Git graph such a mess if we use Git Flow? Or it's not only happening for Git Flow, it's only if you merge a lot, right? If you merge different branches into like feature branches, merging back and always only merging, then you get these weird Git history with these graphs that go like that are side scroller at some point. And of course, Git merges are totally safe and are the default behavior of Git. But like I said, they mess up the history a bit and make it kind of totally useless for the human eye to understand what's happening there. But why is that? So let's have a look at Git merge. So we have a feature branch. In this case, the red dots are the feature branch. And when we merge them back into the master, and nothing happened in the master when everything's fine. So this is a fast forward merge. Everything's fine, no merge commit, cool. But if something is happening in the master branch in the meantime, so another feature gets merged, if we want to merge our feature branch, then Git does this for us, but it creates a merge commit. And that's pretty smart, because what Git is doing here is guesswork, right? It takes the feature branch and takes the master branch and says, it's not, there's something in there I don't really know about, but I try to not mess it up. And normally Git does that pretty well, so that's quite safe. But now if you want to go back, and you wouldn't have the merge commit, you would have to figure out what kind of commits you've merged, and you would have to remove them one by one, and that would be really annoying. So the good thing about the merge commit is, if you undo the merge commit, then all the merge commits are gone as well. So that's really, really nice. So it's a kind of a safety feature, right? So really cool. But the alternative, what can we do instead, is we could rebase. And rebasing means we would take our commits, or would tell Git to move them somewhere in a safe place, store them, then get the updates from the master branch, and then reapply your commits again. And it was quite subtle in the slides, but the colors of the commits changed from red to purple. And that's really, really important, because now there are new commits. So completely new commit objects with new Git hashes and everything. So you changed the history. And that's why some people consider rebase dangerous. And it is, if you rebase stuff that exists outside of your repository, then it could be dangerous. So don't do that. Please only rebase stuff that you only know of, local branches or something like this, or branches that you're really 100% sure nobody else is using than you. But what does that mean? So now Git thinks your feature branch started at the current head, so the current position of the master branch, and now you can merge it again fast forward without any merge commit. And that's quite nice, but that has a drawback. If somebody says, I found a bug in your feature and we have to undo the merge, now you have no idea how many commits you merged. So you have to, maybe the log is good and you know exactly, but if you merged like 23 commits, most of the time you roll back 22 or 24. So, and that sucks, right? So the better alternative is to tell Git, so I know you can merge fast forward, but please don't. please create a merge commit anyway, right? Makes sense? No. Because, Sebastian, you told us merge commit are bad and they're messing up our Git history. And yes, they are, but not if we do it in this way. Because if we do it this way, our Git branch or our Git history and the Git graph only contains of 2 lines. It's always the master branch getting out to the feature branch, returning to the master branch. Going out to the feature branch, returning to the master branch. And that's all that we ever see, right? If we do it this way. So it's super clean. We can exactly see what kind of branches merged or brought in what kind of feature. And it's really, really nice to have an overview of what's happening in your software. Some people say, okay, but this is kind of, yeah, you have to check if everything's rebased, and then you have to rebase it all the time and all that stuff. But Git has ways to help you there, right? For example, you can create Git aliases, and you don't have to read it. But you can only see, okay, it's a little bit longer. But what this does is it adds a Git alias that is called Git integrate. And what that does is it makes sure that the branch you want to merge is properly rebased, and if so, it merges it with a merge commit. So normally what you do is you say git integrate my feature X, and if it's properly rebased, it gets merged with the merge commit, and if not, the git command will tell you, no, you have to rebase that first before you can merge it. So that makes stuff a little bit easier and much more convenient. So just you don't have to do everything manually, and you don't have to check everything manually. But like I said, if you never rebased, then please try that in a dummy repository first, not in your main repository of your production application. Because if you do it wrong, you can mess up things pretty badly, right? Like I said, please try to avoid rebasing stuff that's living outside of your repository. But so like the Git book is telling us, if you don't do that, you will be scorned by friends and family. Yeah. So most of the time, coworkers come after you with pitches and forks and chasing you through the office. So what do good Git students do? So try to be very precise and informative in your commit messages, and clean up your mess. And what I mean with mess is everybody tells us to commit often and to make sure you have all the steps of your development process, and that's totally fine, right? You can commit as often as you want and make crappy commits all day, but it's really nice for like the last 5 minutes of your day to say, okay, now I'm going to clean up this mess I created with all these stupid commits and try to make them precise. So what you can do is just before you leave the office, you type git rebase-i. And what this starts the interactive rebase, right? And then you see maybe some commits you did during the day, and you see we have the last commit you did today was the fixed typo one, but yeah, it actually fixed a typo of the second commit, so the superhero fighting skills. So what we can do while rebasing is we can reorder commits, right? We can just remove the line, move and paste it over here. That's quite nice. So we just have reordered it. And what we can do now is we can say, okay, we don't want this commit to stay. We want to create a fix-up. What that will do is it will merge the fix-up commit with the commit on top. And so you keep the changes of both commits, but the fix-up commit will be gone. It will no longer be in the history. So that's quite nice. So nobody will ever know that you did a typo. So, and that's really nice for me because I type like shit, right? I'm really bad typer. So I have to do like fixed typo commits all the time, but nobody knows. So in my team, everybody think I'm a god typer, like 20 finger system or something. Because I clean up that stuff. So when you're ready and say, okay, I just reordered them in a nice way. I combined the stuff that I don't need. Then you save it, and you have successfully rebased your commits. And if you look at the log, now the fixed typo commit is gone, but the fix is still in there. So during the day, you can create like a mess, but still, at the end of the day, you should invest 5 minutes and then clean everything up. And you can do really advanced stuff while interactive rebasing. You can split commits into multiple commits. You can move stuff out of commits. And that's, like I said, it's quite advanced, but give it a try. Create a demo repository and fiddle around with it. In the end, it's not that complicated. It's just practice. You have to do that regularly. Then it's just, like I said, 5 minutes before you leave the office. And the thing is, even if you work alone on a feature branch, sometimes you push that thing to the central repository, because like if your machine crashes, like it should still be in the central repository. So what you have to do is to get your changes to the central repository. You have to force push, right? And force pushing is always dangerous, right? Because it's just overwriting stuff. So don't use -- force ever, right? Please use this one. Use git push -- force -with -lease. And what that does is it makes sure you don't overwrite commits that you don't know of. So if somebody in the meantime changed your feature branch with new commits that you never pulled, then Git will not let you force push your changes, because Git will tell you, no, somebody else did something, and you will crash or their data will be lost. So this is a really nice safety net if you do rebase and force pushes to the central repository. So of course, you can do rebases with shared branches as well, with force pushing. But like I said, please talk to the people that are using the branches, because if you don't, you will not be on their friends list anymore. So, and some tips and tricks that just makes everything a little bit easier to handle that. The cool things that you out of the box can use are Git aliases. And like I said, I'm really horrible typer, so I only use one character aliases, like git p for pull, git c for commit, and git b for branch, and some stuff like that. But you can also create cool aliases for git log, for example, because git log is really, really powerful. Who's using Git on the command line mostly? And so that's quite a lot. Cool. So, and git log is really, really powerful. It can show you like very much information just by tweaking the command by a few characters. And for me, it's much, much faster than using any UI tool and clicking. So what you can do is you can create some fancy aliases that do crazy log stuff. Like once again, you don't have to read that. If you're interested, I will link the slides later, then you can have a look at them. But what they do is, for example, something like this. We type git l, and now we have these like colorful Git graph stuff even on the command line, right? So this is really, really handy. And a nice thing that the terminal has is you can search your Git log very, very easily by using the less command. So if you type / and whatever you're searching, then it will automatically highlight stuff. And then you can type n for the next occurrence, and uppercase N to go to the previous occurrence. And again, that's most of the time much faster than using any UI tools to navigate your history. Anybody of you did this? If you did a mistake, so like a rebase that didn't go that good, you went out of the directory, removed the directory, and cloned it again. Who did that? Okay. I hope you don't do it, or at least I hope you will not do that anymore after this, because Git Revlog to the rescue. And Git Revlog is really nice. It's kind of the history of your Git repository, not in your repository itself. So that's really nice. What it does, it tracks every state your Git repository is in, even during rebases. If you start a rebase, it kind of tracks it, and if you finish the rebase, so you can go back to every state your Git repository was in for quite a long time. So just type git revlog, and then you should see something like this. And even here you can see something like, again, even when we started the rebase here, we have a pointer to the point in time where we started the rebase. So when we want to go back to that point in time before we rebased anything, then we just can go back there. Normally, if you are rebasing, like I said, you're changing commits, you're creating new commits, and the old commits are normally lost. You don't have they are not part of your repository anymore. But Git is clever enough to just keep the objects because the revlog is still pointing at them, and it's okay, there was something that we changed, and I still need that, so I can restore that with the revlog. So what you can do is just type git reset and using the pointers of the revlog, and then you will be exactly at that point in time, and your repository is in the state before rebasing or resetting or whatever you did that made something not working anymore. So we're in total Zen mode. Everything is working perfectly, like always. And then something bad happens, right? Some production bug is happening, and of course, every hands on deck, everybody's fixing the bug and is deploying a fix, and everything's good again. But now, what's happening, the product people are coming to you and say, yeah, that bug, that was really bad, and it affected some customers. And we have to know exactly when that thing went live, because we exactly have to know what customers we have to talk to and make things right with them. So now we're kind of, okay, fine. We were trying to figure out when we deployed the bug to our system. And product has some nice hint and is telling you, okay, but I know like 3 weeks ago, this was working. And you said, okay, cool, I can work with that. So what we can do now is we can look at our history and say, okay, 3 weeks ago, this was working. Nice, cool. So let's go somewhere in the middle and check out if it's working here. And no, it's not. Okay, move further back, check if it's working here. Okay, here it was working. Nice. So it must be either here. No, this is still working. So this is the bad commit. And this is kind of tedious, I would say, to check out the version and check everything and do everything by hand. So it's really nice that Git has a feature for that. And that's really cool. It's called Git bisect. And so what we have to do is we have to tell Git exactly what we marked before. We have to tell, okay, this one is not working, and this one is working. So we have to say git bisect start. And since the current version isn't working, we just say git bisect bad head. So the current state is bad. And now we look for the commit hash from 3 weeks ago, and we say, okay, git bisect good, and tell the commit hash from 3 weeks ago. And now Git already is running and figuring out how much commits are between those two, and is telling you, yeah, we have roughly 2 checks to make to find the bad commit. And then you test everything, and you say, no, this one is still bad. And Git is running again and is figuring out what kind of commit it's presenting you. It says roughly 1 step. Now you say, oh no, this is still bad. And then it says, yeah, okay, now we should have found it. Please test the last one. And then you say, no, no, this is good. And then it comes up with the commit that made everything burn. So that's quite handy. Then just hit git bisect reset, and you are back at your head. And then if you have like the commit that that caused the bug or the error, then you can change, or you can look at your deployment history, and you can check your releases. Okay, when did we put that live? So what was the next release after this commit? When did it went to production? And then we can tell our product people, and they can talk to the customers and make them happy again. But still, checking everything manually is still kind of annoying, right? And telling Git, oh yeah, this is good and this is bad. So what we can do is, just like before, we say git bisect start, mark the good one, mark the bad commit. And then what we are doing is we let Git execute our unit tests. So now we tell him, run our unit tests. And as long as this can be unit tests or any test script, the only thing the test script has to do, it has to exit with exit code from 0 or 1. So in everything's fine, it has to exit with a 0. And if it's not working, it has to exit with an exit code not 0. So Git will always execute the test script and then figure out, depending on the return or the exit code of the script, if the current state is good or bad. And then it runs completely automatically. So you can go for a coffee, and like 5 minutes later, you see, oh, this one made everything burn. So that's really handy. The thing is, if you would have a unit test for the issue, then most likely the issue would never have had occurred. So what you have to do is you have to write a unit test that will show actually that the issue exists. But you have to be careful. You just can't commit it to your repository, because if you commit it to your repository and Git is checking out another version, this unit test is gone. So this is a little bit tricky. What you have to do is you have to write the unit test to a separate file that is not in your repository. So Git will not touch it if it is checking out different versions of your software. And if everything went right and you found the bad commit, then you can take the test and move it into the right file and commit it to the repository. So this has some special things you have to look at, but it's really, really powerful to get to the bottom of where problems has been introduced. And this kind of makes returns to the cycle, right? Because if you're doing small commits, like atomic commits with single, irreducible, useful changes, then if you have the commit that introduced the problem, you can find the problem in your code very, very easily, because it's not like you changed 70 files. Most of likely you changed 5 files or you have a very small change set. So finding the issue and is most likely quite easy. So lastly, I want to talk about Git hooks, because Git hooks are quite nice to actually enforce kind of the rules I was talking about before. So you can create Git hooks that validates your commit message. Everybody, if somebody is committing, the hook gets triggered, and you can validate the commit message. And if somebody doesn't comply to the rules, you can just exit and say, no, you can't commit. So it's quite handy. And those commits, so they're local commits. That's are the ones that are useful for message validation. So when there are like post-checkout, commit message, pre-commit, and pre-push. And if you want to validate the commit message, you actually write a commit message hook. And then you can validate the message before it actually, before the commit actually gets done. And there are remote hooks as well. So you can even implement something on the server side, but yeah, if you want to. So in the end, try to keep your commits small as possible, or as useful, and write precise and informative commit messages, because they make your life much easier to find problems, to identify issues, and all that stuff. And try to keep your history clean, right? Please remove the fixed typo, forgot to add file, forgot to add another file commits to from your history before you actually push it to the central repository. So clean up after yourself. So, and that's all from me. Thank you. Any questions? It's late, I know. Everybody wants to go home. So, it's fine. Thank you.